This video is on section 7.2 notes, law of cosines. So we just talked about law of sines previously, and we also have law of cosines, and we know that the two laws, the two sets of formulas are used in different circumstances. So law of cosines is used in two specific circumstances with triangles. In one, you have two sides and an angle that's in between them. And in the other situation, you have three sides of a triangle given in the problem. Now, with the law of cosines, we can see that the formula is quite a bit more complicated than the law of sines formula, and there are three versions depending on which side length is isolated or almost isolated in the formula. And my recommendation to you would be not to memorize the formula specifically, but to memorize how the formula works or kind of like the pattern of the formula. So the way that that helps me to kind of remember it is I think of, we've got one side length squared and then the other two side lengths squared. Pythagorean theorem is just what this reminds me of. So one side length and then the other two. If you notice, this side length is A and then this is cos of alpha, and so the beginning and the end are related. They're not the same. We've got a side length and an angle, but it's the same letter. And then the interior is also the same. So this was one side length, this was the other two, and then we have -2 times the other two. And so that's how I always remember it. I think Pythagorean theorem first. I know the outsides are related, I know the insides are related. And that's how I kind of set up every single problem. All right, so as I use that method, I'll talk you through it. If you need to have all three of these formulas written down and actually look at them every time, obviously that's totally fine as well. So here in our first example, we're going to look at a triangle that gives us side, angle, side information, and we're going to solve that first. So the example says the wing of the F-106 Delta Dart is triangular in shape with the dimensions given in the figure below. Find the length of side C. So here they're not actually asking us to solve the triangle, so they just want us to find a specific side, but we could use law of sines to solve for the other angles if we needed to. But here to find side C, I'm first going to go ahead and write down the information I have just to prove that law of cosines is the method or the formula that is the best. So if I highlight the information that they gave me in the triangle, I can see that it's a side and then an angle and then another side. So side, angle, side is the information, and so law of cosines is what we'll be using. So C is what I'm solving for. C squared equals, so then I'm going to write the other two sides squared. So 37.6 squared plus 19.2 squared, and then I'm going to have -2 multiplied by the other two sides. So 37.6 times 19.2, and then last I have cos of the angle that's across from this side. So cos of the angle across from C is 68. Cos of 68. So just like with the law of sines, we're dealing with triangles, and so we want to make sure that anytime we hit the cos button or the sine button or whatever, anytime we use any of these trig buttons, we're always checking the mode of our calculator. And in this case, with triangles, we're going to make sure that the mode of our calculator is in degrees. And you could see I had just cleared my calculator before I made this video. And when you clear your calculator, the default is radians. So if you are someone who clears your calculator often, you're going to need to go back and put it in degrees. All right, this is probably the simplest thing to solve for a missing side. You just have to plug in everything and then square root it. So 37.6 squared plus 19.2 squared minus 2 times 37.6 times 19.2 times cos of 68. So C squared is approximately 1,241.5. And then to solve for C, you can square root this number, or you could just take it and raise it to the 1/2 power. So I like raising it to the 1/2 power because you can do it just like that. But if you wanted to square root that number, you could just put square root and then copy paste it in there. Either way, you get the right answer. So for this, I'm going to go ahead and write it to the nearest tenth, since the textbook seems to like that for this unit. 35.2 feet. But obviously when you're working in my math lab or if you're taking a quiz or a test, pay attention to what the problem asks you as far as rounding. Okay, so there is our side angle side example, solving for a missing side. Here next we have an example where they're giving you all three sides. And if they give you all three sides of a triangle, then that means obviously all we have to solve for, if we needed to solve the triangle, were the angles. And in this situation, we're always going to find the largest angle first. And the reason that we do that is because some people choose to mix formulas. They might start with the law of cosines and then switch to the law of sines because that's a simpler formula, which makes sense. And in that case, you might inadvertently use angle side information and create an ambiguous case and not even recognize that's what you've done. So if you find the largest angle first, since the law of sines ambiguous case is typically based off of acute angles or smaller angles, then by finding the largest angle first, we can kind of avoid having any consequence when we use the law of sines. So that's beneficial. Now, I'm a little different in that I say if you started a problem with law of cosines, you should finish the problem with law of cosines. And one of the reasons I say that is because my background was in teaching high school, and that way we could just avoid the ambiguous case altogether. So I'm going to be consistent with that here. If I start a problem with law of cosines, I'm just going to do the whole thing with law of cosines. But I did want to explain to you guys why this is a rule that we work with. All right, so I'm just going to label this triangle alpha, beta, gamma. So this would be side A, side B, side C. A is 8.2, 3.7, 10.8. And so if this is side C and is the longest side, then it would correspond to the largest angle. So gamma would be the first angle that we would solve for. So I'm going to say 10.8 squared equals, because I know that this side that is almost isolated, that the outsides of the equation are the same. So it's side C and angle C. Equals, and then I'm going to add the other two angles, sorry, the other two sides, 8.2 squared plus 3.7 squared, and then minus 2 times the other two sides, 8.2, 3.7, and then cos of the angle that corresponds to this side, so cos gamma. Okay, so if we were to simplify this, we would have a number here equals a number here minus a number times cos gamma. We would have a number equals a number minus a number times cos gamma. This is what we would have. And so if I was to go about solving this, I would just take this number and subtract it over, and I would divide by this coefficient, and then I would have cos gamma isolated. But there's a lot of decimals in here, and so if we were to start to simplify this, we would have a lot of room where we could make rounding errors if we started to round decimals right now, and then we'd have a lot of copy pasting. And so the strategy that I typically use if this is the type of problem that I'm solving for, and I'm solving for an angle, is I just leave it all until the end to plug in. So what I do is I say, well, to isolate this cos, I have to subtract numbers over before I can do something that would require dividing, and these numbers end up being a coefficient of cos, and so they have to be divided over. And so the first thing I would do is I would take this and subtract it over to the left side. So I would say 10.8 squared minus that whole group of numbers. So 8.2 squared plus 3.7 squared I would just subtract that whole group over. And then once I've subtracted that whole group over, now this number's gone, and so I'm free to take that coefficient and divide it over to the left side. So then I would take this whole coefficient and I would divide it over. So 10.8 squared minus 8.2 squared plus 3.7 squared divided by -2 times 8.2 times 3.7 is cos gamma. Okay, so I'm going to go ahead and type this in as a whole group. Okay, so this is equal to cos gamma. So cos gamma is approximately -0.6. And remember, just like with the law of sines, here we have cos equals something. Cos is adjacent over hypotenuse. The graph of cos bounces between -1 and +1. We should always get a decimal here. So some sort of decimal that's negative or positive, it doesn't matter, but that decimal should be smaller than 1 or greater than -1. It should be a decimal that's not bigger than a whole number. So cos gamma is -0.6 approximately. So now I can do cos inverse 126. All right. And you could store this if you wanted to. I don't think we don't need to store this. So I'm just going to leave it there. And then I'm going to get ready to use the law of cosines to find my next angle, and I'm going to go for the next biggest angle. So we use 10.8 for the biggest, 8.2 is going to be the next biggest. So 8.2 squared plus 10 equals, adding the other two angles together, -2 times the other sides. I said angles, I meant sides before. So side squared -2 times the two sides. And then cos 8.2 is across from alpha, so alpha is what we'll be solving for. And so just like I did last time, I'm going to start with this number. I'm going to take this and subtract it over. And so that equals this stuff times cos alpha. And then once I have that, I can take this stuff and divide that stuff over. So divided by -2 times 10.8 times 3.7. And that will isolate the cos alpha. So I have 8.2 squared minus 10.8 squared plus 3.7 squared divided by -2 times 10.8 times 3.7. So I end up getting cos alpha is this decimal, and the decimal should be between -1 and +1, so that's a good sign. Cos alpha is approximately 0.8. $37.9. And so then to find the last angle, we can just do 180 degrees minus 126.1 minus 37.9. And at this point, using rounded numbers, it's not really good math to do, but it probably won't make a difference. I'm going to go ahead and just copy paste these anyway. In the case where we're doing one decimal place, it won't make a difference for your answer, but it could make a difference for your answer if you are rounding to 3 decimal places. So it's good practice to do what I did and to copy paste. And the funny thing here actually, the funny thing here actually is we get 16.1, and if we had used the rounded decimals, we would have gotten 16.0. So there's our lesson right there. We should always use the unrounded numbers to do our calculations so we don't get a rounding error. All right, we have an application problem. So this problem says Andrea and Carlos left the airport at the same time. Andrea flew at 180 miles per hour on a course bearing 80 degrees, and Carlos flew at 240 miles per hour on a course bearing 210 degrees. How far apart were they after 3 hours? Okay, so before I draw my triangle, I'm just going to say here's the airport in the middle. I just need to get a good picture of what the sides of the triangle are kind of looking like here. So they're starting at the airport. Andrea flew 180 miles per hour on a course bearing 80 degrees. So starting up here, bearing 80 degrees, just like there-ish. So that's Andrea. Okay, Carlos flew 240 miles per hour on a course bearing 210 degrees. So 210, 90, 180, plus a little bit more. So Carlos is going this way. Carlos. Okay. How far apart were they after 3 hours? So Andrea did 180 miles per hour for 3 hours. Carlos did 240 miles per hour for 3 hours. So this is just helping me to draw my triangle. I know that this kind of side of the triangle is going to have these kind of angles like this. Or like, yeah, it's going to have an angle like that. I'm trying to figure out how long the sides should be. So in 3 hours, Andrea went 540 miles. In 3 hours, Carlos went 720 miles. Okay. Okay, so here's Andrea, 540, 700, that looks a little bit longer, 720. So this is me trying to do a good job drawing my triangle. Okay, so you can see here's my axis right here. Here's my bearing of 80, and then my bearing of 210, so you can kind of see the two angles there. We know Andrea had gone 540 miles. Carlos had gone 720 miles. We can figure out the angle that's in between them. So if this is bearing of 80, that means that this is 10 degrees. We know this is 90 degrees. 90, another 90, so this was 180. To go to 210 was another 30 degrees. Okay, so this angle in between them, that's 100, 130. So this angle is a 130 degree angle. All right, so we have a side angle side triangle. And the question is, how far apart were they after 3 hours? So this is their distance because each of them is flying outwards, flying that way, flying that way. So we're just solving for this x. Okay, so I'm going to say the distance between them, x squared, is the other two side lengths squared. So 720 squared plus 540 squared minus 2 times 720 times 540 cos of 130 degrees. Cos of the angle that's across from the side. Okay, so we just need to plug this all in. That's a large number. Okay, so x squared is approximately 1309831.6. 1,309,831. Okay. And so now I'm going to square root that. So raise it to the 0.5 power, or you can actually square root it if you want. So they are approximately 1,144.5 miles apart after 3 hours. Okay, so that's it for the law of sines, law of cosines. Here were our law of cosines examples. Now, there are two new formulas for finding the area of a triangle that we're going to look at. So traditionally, we learn that the area of a triangle is 1/2 times base times height. And when they say height, they mean the altitude of the triangle. So from the distance from the base to the very top, tippy top of the triangle. The unfortunate part of this formula is that sometimes you don't know the length of the base. Sometimes you don't know the height or the altitude of the triangle, and it makes it so it's difficult to find the area. So today we're going to learn two different area formulas that are a little bit wonky, but are kind of convenient because you can find the area of a triangle when you're given different information. So this first one was actually from section 7.1, but I felt like we'd learned enough that day. So if you do the recommended textbook problems, you'll notice that you're going back to 7.1 to do some of those problems. So the first formula comes from information in a triangle that is side angle side. And so you can memorize these three variations, or you can just say, I should have the information side angle side. And what I do is I do 1/2 times the two sides multiplied by sine of the angle that's in between them. And that's the easier way. You don't have to memorize all these different letters and keep them straight. Just know 1/2, two sides, sine of angle in between, and then you'll get the formula right every single time. So for this first example, it says the town of Hammond is considering the purchase of a 4-sided piece of property. This 4-sided piece of property looks rectangular, but if you notice, the angles are not 90 degrees in the corners, so this is not rectangular. All right, so they want a 4-sided piece of property to be used for a playground. The dimensions of the property are shown in the figure to the right. Find the area of the property in square feet. And so we have area 1, area 2, first triangle, second triangle. Each of these triangles have side, angle, side information, side, angle, side. The reason that I'm using these kind of corners, side angle side, is because I don't have this diagonal across here. So I cannot do side, angle, side. I can't do that. Or side, angle, side. There's no other way I can find the triangle area except by doing side, angle, side. So for the first triangle, the one that's labeled A1 or area 1, I'm going to do 1/2 times one side, so 148.7, times the other side, 93.5, times sine of the angle that's in between them, so 91.5. Okay, for the other one, I have 1/2 times the two sides, so 100.5, 155.4 times sine of the angle that's in between them, so 87.2. And that's it. I just got to type it into my calculator and see what I got. So 1/2, 148.7, 93.5 sine 91.5. So the first one is 6,949.3. $7,799.5. And so if we add them together, 14,748.9 square feet. So 14,749 square feet. They didn't tell us what to round to, but near a square foot would probably make sense. Okay. Then we have a formula that works if you only have the side lengths of the triangle. While the last formula doesn't really have a name, it's just like another area of a triangle formula, this one does, Heron's formula. So for this one, you find S, which is a like partial perimeter. So you find the perimeter of the triangle and then divide it in half. And then you use that and plug it all back in. So that partial perimeter times the partial perimeter minus the first side times the partial perimeter minus the second side times the partial perimeter minus the third side. So we'll go ahead and draw a picture of this one. Whenever I draw my triangles to label, you've probably noticed this by now, I don't draw them to scale because that's just too much effort. So 220, 234, 160, there we go. And so for S, we're just going to add these all together and divide by 2. It's not an average because you're not dividing by 3. You're just, I don't know, partial perimeter. Okay, 220, 234, 160. Divide by 2. S is 307. If you wanted to make this easier for yourself to type, you could even store this as a letter so you don't have to type 307 each time you use it. It doesn't really matter. So this formula is going to be 307 times 307 minus 220 times 307 minus 234 times 307 minus 160. I'm going to store it as x. Okay, square root. And so now I don't have to type the 307 because I put an x in there. So I'm just going to use x every time. X minus 220, x minus 234, x minus 160. See how much faster that was than if I'd been typing 307 each time? See, it's kind of nice. Okay, so A is approximately 16,929.7 feet squared. Oh, what is the asking price? We're not done yet. So it says $45 per square foot. So we're going to say this number, I'm not going to round it, times 45. So I'm going to use that decimal in my calculator. I'm going to multiply it by $45. So $761,835.88. There we go. So this was your area, and then this is the asking price for the lot based on $45 per square foot.